Alright, so today we're taking a look at AP Stats from the 2016 exam, the fifth question. A polling agency showed the following two statements to a random sample of 1,048 adults in the United States. Okay. An environment statement, protection of the environment should be given priority over economic growth. Economy statement, economic growth should be given priority over protection of the environment. Okay, so identical to swapped. The order in which the statements were shown was randomly selected for each person in the sample. After reading the statements, each person was asked to choose a statement that was most consistent with his or her opinion. The results are shown in the table below. Percent of samples, so 58% said environment statement, 37% said economy statement, 5% said no preference. Okay. Assume the conditions for inference have been met. Construct and interpret a 95% confidence interval for the proportion of all adults in the U.S. who would have chosen the economy statement. Okay, so make sure we're looking at economy. So let's just highlight some things. Draw, highlight. Economy statement. So we're using the 0.37. So we should probably do the four-step process. So as follows. 95% confidence level. This is a one sample Z interval. We are allowed to assume the conditions for inference have been met. Now let's see if anything else. Let's see, we talked about the procedure to use. We talked about the 95% confidence level. Okay, we're good. So now we can go ahead and write the general formula. So I think we know the population proportions, so we can use p hat. So p hat plus minus, and then this is z star, because this is proportions. Z star times square root p hat, 1 minus p hat, over n. So it's going to be 0.37 plus minus. So then for z star, if you go ahead, go to your reference sheet, it's all the way at the back of the test, the one that you want to use. It's table B, the t distribution critical value table. You go ahead all the way down to where it says 95%, and then you use the infinite row because you're doing proportions, so use the infinite row, and then you match them up, and you get your z star to be 1.96 times square root of 0.37 times 1 minus 0.37 over n, which was 1,048. Sorry, when I said p hat, we don't know the population proportion. That's why we're using p hat. We're using the estimate. We don't know the population proportion. We know the sample proportion. Therefore, we use p hat. Just correcting what I said earlier. Okay. And then close parentheses. So when you go ahead, you put this into your calculator. Again, that's your point estimate. That's your margin of error. So margin of error was equal to 0.03, I believe. Yes. So that's going to be 0.37 plus minus 0.03, which is 0.34, comma 0.40. So now you can say, let me just switch the colors. We are 95% confident that the interval 0.34 to 0.40 captures, and now I'm taking the rest of this statement directly from the question, captures the proportion of all adults in the United States who would have chosen the economy statement. Captures the proportion of all adults in the U.S. that would chosen the economy statement. Okay. So now we can move on to part B of this question. One of the conditions for inference that was met is that the number who chose the economy statement and the number who did not choose the economy statement are both greater than 10. Explain why it is necessary to satisfy that condition. Okay, well that's the normal condition. That n times p hat and n times 1 minus p hat is greater than 10. If those two values are greater than 10, it is safe to say that your distribution is normal. Each family distribution has normal distribution. So, but there's a little more to that, and now this is what a possible response. So part B, you can say this. This normality condition is necessary to satisfy because the formula for the confidence interval, I'm just gonna abbreviate it, confidence interval, relies on this binomial, because this is a binomial distribution. There's two outcomes, either this or that. That's why it's binomial. And yeah, there's other conditions that you should know by now. On this binomial distribution, and okay, this normality condition is necessary to satisfy because the formula for the confidence interval relies on this binomial distribution. Oh, right. The binomial distribution can be approximated by a normal condition, normal distribution, not condition, normal distribution, and this can only be true if np hat and n1 minus p hat are greater than 10. Okay, that's part B done. Possible answer to that. Now, let's see part C. A suggestion was made to use a two-sample z-interval for a difference between proportions to investigate whether the difference in proportion between the adults in the U.S. who would have chosen the environment statement and the adults in the U.S. who would have chosen the economy statement is statistically significant. Is the two-sample z-interval for a difference between proportions an appropriate procedure to investigate the difference? Justify your answer. Alright, well, the problem with the two sample z interval is that the data needs to come from two independent sources, two independent samples. All this data came from the same sample, so you could say something like this. Question C. Typically, a two-sample z interval, z confidence interval, can be carried through if the data come from two independent samples. since the data come from the same, oh, whoops, the same, not come from the same sample, this condition, like it's typical, this, so we can call it a condition. This condition is not necessarily met, therefore it would not be appropriate to use this to sample Z interval procedure to investigate the difference. It's a lot. It's a mouthful. But I guess you could be more concise, but I think this is the most concise that you could possibly be. So yeah, this would be an adequate response to question 5 from the 2016 exam.